By the end of this lesson, you should be able to measure physical quantities using appropriate instruments, explain accuracy and consistency, explain sensitivity, observe the students in this laboratory. What are they doing? Of the 3 instruments being used, which would you choose to measure the thickness of a book? Why? What do you notice about the readings obtained by the students? What is the thickness of the book? The students measure the same book, but their readings are different. Why? The readings are slightly different because the instruments have a different sensitivity. Which instrument is the most sensitive? Micrometer screw gauge. Which measurement is the most accurate? Why? 1.487 centimeters. It has the most number of decimal places. When we measure a physical quantity, we also need to consider its magnitude before choosing an appropriate instrument. For example, if we want to know the height of a table, would we still use a micrometer screw gauge since it is the most accurate? The magnitude of the quantity should not be more than the maximum capacity of the instrument. The instrument must also be sensitive enough to detect and provide a meaningful measurement of the quantity. Look at the 2 readings. What is the difference between the 2 readings? The reading of the digital stopwatch has 2 decimal places, while the reading of the analog stopwatch has 1 decimal place. Which reading is more accurate? "12.44 seconds. Which stopwatch is more sensitive? The digital stopwatch. Two groups of students are measuring the time taken for 10 oscillations of the same pendulum. This is what Group A did. This is how Group B got their measurements. These are the results of Group A and Group B. What can you say about the measurements of Group A and Group B? We say that the readings of Group B are more consistent. Let us look at the video again. Why do you think Group B has more consistent measurements than Group A? Did they take their measurement in the same way? Group A started their stopwatch at the same time as the pendulum's swing. Group B allowed the pendulum to swing before starting the stopwatch. By doing so, Group B reduced the occurrence of human error due to reaction time. Therefore, they obtained more consistent results. We have just learned about accuracy and consistency. To gain a better understanding of accuracy and consistency, let's look at this video. Which contestant's throws are more accurate? Contestant A is more accurate. His throws are uniformly around the bull's eye. Which contestant's throws are more consistent? Contestant A is more consistent. His throws are more close together. If we were to equate the throws of the boys to measurements, could you explain the accuracy of measurements in another way? Most quantities that we measure have a specific value. For example, the density of water, the body temperature of a healthy person, the wavelength of red light, the length of your laboratory table, manufactured according to specifications, etc. A measurement we make of these quantities is accurate if the measurement is close to its specified value. A marksman fires 3 shots. Describe his shots in terms of accuracy and consistency. His shots have good consistency, but poor accuracy. Another marksman fires 3 shots. Describe his shots. His shots have good accuracy, but poor consistency. The marksman, unhappy with his previous tries, fires another 3 shots. Describe his new set of shots. His shots have good accuracy and good consistency.
Meena, Mary and Malika were asked to measure the diameter of a test tube in the laboratory. The actual diameter of the test tube given by the manufacturer is 2.75 centimeters. Each of them measured the diameter 3 times at 3 different places on the test tube. The measurements are shown in the table. What instrument was used to measure the diameter of the test tube? What instrument should we use to get more accurate readings? from the 3 sets of measurements determine which set is accurate and consistent, which set is consistent but not accurate, which set is not accurate and not consistent. Drag and drop to complete the table.